In computer science, quantization is a process of splitting the set of continuous or discrete values into a finite number of intervals. Quantization is used in signal processing, including audio-video compression processes. In the elementary quantization, an integer value is divided into natural numbers. Such number is called a quantization factor. In uniform linear quantization, the set of values is split into equal intervals. In other words, an input value is divided by constant value, quantization interval, and an integer part is taken from the quotient. Please do not confuse quantization and discretization, and quantization interval with discretization interval respectively. In discretization, a time variable value, signal, is compared with a present interval, discretization interval. Thus, in discretization, the signal is split against the time component, horizontal component, as shown in the plot. Quantization brings a signal to preset values by splitting it across the level, vertical component, as shown in the plot. Signal processed through quantization or discretization is called a digital signal. In signal digitalization, quantization level is called a discretization depth or bit count. Discretization depth is measured in bits and stands for the number of bits specifying the signal amplitude. The higher discretization depth is, the more precisely a digital signal corresponds to an analog one. In uniform quantization, discretization depth is also called a dynamic range and measured in decibels. 1 bit roughly corresponds to 6 decibels. In level quantization, sample values are represented by digital signals. In binary quantization, the range of signal voltage from Umin to Umax is divided into two intervals. The value of the yielded interval, quantization interval, is expressed by the formula. N-bit binary code, which is the number of interval expressed by binary number, is assigned to each interval. The coded interval where the voltage of a sample lies is assigned to that signal sample. Thus, an analog signal is represented through a sequence of binary numbers, which correspond to a signal value in certain moments, i.e., by a digital signal. Note that each binary number is represented through a sequence of low and high-level pulses.